Hello, everyone. We are the team Typesetters. I am Andre.
And I am Manjul.
I'm Nishant.
I'm Marijuan.
This study compares the accuracy and efficiency of different input methods on soft keyboards. I would start by introducing the soft keyboard. Popularly known as the on-screen keyboard, it is a system that replaces the need of a hardware keyboard on a computing device or handheld device, thereby increasing the mobility and the use of these devices. The on-screen keyboard contains a direct image map of keys that are translated to the corresponding characters being typed. On most modern soft keyboard, special text prediction algorithms aid in recognizing character patterns and the likelihood of setting keystrokes even before the user types, therefore increasing the efficiency of the text entry. One advantage of the soft keyboard is that it enables people with disabilities or special need people to use the computer. As you probably know, there are lots of keyboard layouts available out there, and a simple Google search would yield thousands of articles pointing to this fact. However, the focus of this research is a study on the QWERTY and the 3x4 keyboard layouts, as these are seen in a wide variety of devices, ranging from the smartwatch to the smartphone. The QWERTY keyboard layout is a Latin-based keyboard containing Latin characters and belongs to a family of other letter configurations. This family can be divided into three, according to where the Q, A, Z, M, and Y keys are placed on the keyboard. Though very popular, the QWERTY keyboard was not designed to be ergonomic, as it has a high same finger ratio, which increases the strain to the user. The 3x4 keyboard layout, otherwise known as the T9 keyboard, is popular with older devices and devices with small screens that wouldn't fit the QWERTY layout nicely. One advantage of this layout is the speed on text entry due to its large buttons and the simple 9-grid systems. This mode is very suitable for people who have problems with small keys. Also, older adults with reduced motor skills would benefit from the larger keys found on the 3x4 keyboard layout. There are several input methods on the soft keyboard, with examples including tap typing, gesture typing, and other less popular, which include bimanual gesture typing and tilt-based typing. For the purpose of this research, we'll be focusing on getting the efficiency of tap and gesture-based input method on the QWERTY and the 3x4 keyboard layouts. The motivation of this research study include the T9 predictive text on the 3x4 keyboard layout allows for larger keys to interact with. Hence, it reduces the spatial touch point errors. The T9 layout reduces swipe distance when using gesture typing for longer words. And finally, older adults tend to type slowly. Hence, we are interested in finding out how they would perform on both keyboard layouts. In prior research, Lin et al. Compared gesture and tap typing behavior of older adults with young adults. Their major finding is that gesture typing is well suited for older adults despite the degradation of motor control ability. One limitation of their study was that they stated that gesture typing was easy to learn achieving a high performance rate after being exposed for 20 minutes while having zero prior experience to using the gesture-based input. Hence, our research is focused on comparing the efficiency and accuracy of different input methods on soft keyboards.
For conducting this research, we wanted to evaluate how the users performed while typing using the different input methods and keyboard layouts. So to test their typing efficiency, we needed some phrases which the users can transcribe from their phone's soft keyboard. We used the phrase sets developed by McKinsey and Sukharov, which are specifically designed for evaluating text entry techniques. These phrase sets provide sentences of optimal length and they have comparable statistical properties. To present these phrases to the users, we developed an Android application which allows the users to see the presented text and then transcribe it using different types of keyboard and input methods. Here is a screenshot of the application we used. We used an open source application called AnySoft Keyboard, which has a feature for turning the keyboards to a 3x4 T9 layout, and it also supports gesture typing. For testing the QWERTY layout, we use the default keyboard provided on Android systems. We also developed a keylogger application which recorded users' input from the soft keyboards. This application used the accessibility feature of Android, which gave us permissions to record and access user input data. The user would turn it on from the accessibility settings of their phone, as shown in this screenshot. We use the following classes provided by Android to record data whenever the user changed the text, focused on the text editor, or clicked anywhere on an action button. With these three actions, we identified users' keystrokes on the soft keyboard. This recorded data was then sent to a PHP server with the corresponding timestamps and participant information. Here's a small snippet of the recorded data on the server. These two applications, when combined together, allowed us to capture whatever the users typed on the soft keyboards and make a record of it for further evaluation. To test and compare the typing accuracy and efficiency of different input methods, we conducted a within-subject experimental study with 5 participants. All of them are students between the age of 22 to 29. The participants were housemates of the experimenters and were recruited to participate in this study as working with outside participants was not possible because of the COVID-19 situation. The experiment was conducted individually with each participant in their natural setting, that is, their home environment. The researchers were present in the same room as the participants while conducting the experiment. They set up the test application and made observations on the experiment. We used our own mobile devices as the testing device, as we are using a keylogger application which could raise privacy concerns of participants' data if installed on their phones. The procedure for conducting the experiment was straightforward, where the researchers gave the participants a pre-set up mobile device and ensured that the keylogger application was enabled before starting the study. The participants were asked to transcribe 10 phrases using each of the 3 input methods. They were also given 10 phrases separately to practice gesture typing on a T9 layout keyboard. This data collected from the practice sessions was not used for the final analysis. Here are the screenshots for the application while conducting the experiment with each input method. The collected data was evaluated to compare the input methods over 3 metrics, which are the time taken for typing each phrase, the error rate for each phrase, and the efficiency of typing. The error rate was calculated using the minimum string distance algorithm, which takes the presented and the transcribed string and outputs the error rate, which is measured by the differences between the two strings. You can read more about this algorithm from the link provided in the references section. The efficiency of each input method was calculated by the keystroke ratio metric. This was calculated by counting the number of keystrokes that the user used to complete a phrase and dividing it by the number of keystrokes that are ideally required to complete the phrase without making any errors. The values of these metrics will be presented in the subsequent analysis section. We also conducted a post-study survey to collect qualitative data about the participants' experiences of typing using tap and gesture input methods on the two keyboard layouts. Their responses are presented in the results section. Now I will transfer the control to Nishant to take the presentation further.
Thanks, Manjul. To analyze the data collected, first we performed descriptive statistics and found the mean and standard deviation of the three different input methods. And after that, we performed repeated measures ANOVA tests to find the significance of the results that we found for the three input methods. So the three different input methods are displayed as the three different input methods are displayed as the three treatments in the table shown over here. For all the three metrics, that is for the time taken, for the error rate, and for the keystroke ratio, we found that the results are significant at p less than 0.05. The results from the study shows significant difference between the three different input methods. And it is very easy to figure out from these three graphs of the average time taken, average error rate, and average keystrokes ratio that tap typing in QWERTY keyboard performed really better while comparing to the other two input methods. Also, the mean for all the three metrics for type 9 gesture was significantly higher than the QWERTY keyboard. From the post-study questionnaire, we found that all the participants agreed that the range of finger movement needed was lesser while using the gesture on T9 keyboard. And also 4 out of 5 participants agreed that it was a challenge typing with smaller keys when compared with bigger keys. One of the participants commented that it was difficult to type the words which had multiple letters from the same key in T9 keyboard. And also one of the other participants suggested a solution for the same problem, that long press feature can be used to select between the letters from the same key in T9 keyboard.
According to the results, Tina keyboard seems to be inferior to QWERTY keyboard in several aspects, while QWERTY keyboard is more accurate and more efficient than Tina keyboard. Actually, there are only the results based on the data obtained from users who are not familiar with the Tina keyboard, since the data is heavily affected by the user's proficiency. However, even based on such data, we can still see some potential of the T9 keyboard after excluding the content deeply affected by the user proficiency, especially for some users who deem that they need to pay more attention to operations requiring larger finger movements. They may have a certain psychological pressure when using QWERTY keyboard, as the range of finger movement is smaller when using a Tina keyboard layout to enter a phrase. Additionally, users might become more cautious while using a keyboard with smaller key areas. And this situation can also explain some performance advantage of QWERTY keyboard as a result of a trade-off, which may indirectly indicate its possible disadvantage in some other areas. As for limitations, definitely there are several aspects that are not fully completed in the study, especially the scale of the test is not large enough. It means that the number of samples is insufficient and the test time is too short to allow users to have the necessary proficiency. According to the observation and experimental data, the performance of the TINA keyboard is supposed to be quite different from its real level because the participants are not familiar with the TINA keyboard. And on the other hand, the performance of the AnySoft keyboard, which might be the only available keyboard supporting gesture typing with TINA layout and was adopted in this study, is not sufficiently optimized for the input under the TINA layout. According to the limitations mentioned above, it is primary and necessary to solve the optimization problems of the existing TINA keyboard that have limited performance of its built-in prediction algorithm. We believe that the TINA keyboard can reduce the performance gap with the QWERTY keyboard to some extent while preserving its own advantage after it has been sufficiently optimized in prediction algorithms and other aspects. Then, it is reasonable to perform a longitudinal study over a long period for specific demographics such as older adults who may already have a high level of proficiency or acceptance of the TINA keyboard. There are the references. Thank you for your attention. Done.